In this video, I'm going to draw the transition diagram for a single server queuing system. A transition diagram visually depicts the possible states of a queuing system and the transition between them. So when you are having a single server, we start with the state where we have no customers. So if we have no customers in the system, we denote that state by S not. So if we have no customers, we can have an arrival. And when you have just one arrival, that means that the state will change so that there will be one person in the system. And the arrival rate we usually denote it by a lambda. So when we add one customer in the system, when we have 0, so it will go to S1. But if another customer comes in, when the first customer is still being saved, that means it will add to the one customer that is already there, so that it will transform to S2. We would have two customers in the system. So we can go on adding until we have S3, S4, S5, and so on. But if your system has a capacity of n customers, we can go on to the one which is before n, that's n minus 1. So I'll just indicate it by a dotted line. That means we'll be at Sn minus 1. We are just saying it's before the last one. Then when we move from this one, which is before the last one, we will go to the last one, which is Sn. So if we are at Sn and this customer is saved, what we'll do is we'll go back to the one which is before it. So we'll go back to Sn minus 1. And when you are going back, this is indicating that the customer has been saved. And we usually denote the service rate by a mu. So we can go on back until we get to the S2. And S2, we are saying two customers in the system. If we have two customers and one is saved, then we will remain with one. If we have one customer saved, then we will go back to 0. So what we are having there, that's the transition diagram for a single server queuing system.